at this point we're halfway done. We have the driver's side head completely put back together and leak free. I'm going to continue to do the same thing with the other side. However, it's going to be pretty much the same thing, and I don't want to bore you with repetition, so I'm going to leave most of that work out unless I come across something that's a little unusual or different. And as far as putting it back together, it's going to be just the opposite of what I did to get to this point. You could probably watch the first 5 or 6 video series in reverse and see where I'm going. So I'm going to be fairly brief putting it back together, with the exception of things like the cylinder heads, the lower intake manifold and upper intake manifold, which require a specific torquing sequence. So I'll go into more detail at that point. And I guess the thing that I've learned with this project so far is that the valve lapping is pretty darn important. This is my 4th or 5th engine rebuild. The very first one I did do the valve lapping. However, I did not test the integrity of the valves before putting it back in. So for all I know, it was leaking a bit. And for the other motors up until this point, I didn't even bother doing that. I just looked at the valves. Yeah, they look good. Threw it back in the car, and I lucked out. They ran pretty good. However, it does make me wonder, could it have run better? Could it have better fuel economy? Would it have more power? Would the engine have longer longevity? Those sorts of things. These are answers I'll probably never know, but the answer is probably yes. So anyway, from now on, anytime that I have a cylinder head out of the car, I'm definitely going to test it for leakage before I put it back in. It's just such an easy step to do. It'd be crazy not to. So anyway, with that in mind, let's get started. Yeah, you can really see the discoloration here where the exhaust was blowing back into the intake. So anyway, this should clean up pretty easy. Yeah, those marks on the valves, that was just the result of running in the driveway maybe for a half hour or so. I can only imagine what would happen if I'd actually taken it out on the road and gave it some power. We probably would have started burning these valves in pretty short order. Alright, I just finished valve lapping the other head, and it looks pretty good too. Did the liquid leak test, and they came out really well with very, very minimal leakage. So I feel really good about this at this point. So let's go ahead and do a leak down test the proper way. So we have it disconnected right now, and we'll crank the pressure up here until we get to 0 on the right gauge. So about right there, and we'll note we're right there at 31 psi. So I'll crank it back down here while I hook it up, and I'm going to hook it up to cylinder 5, which was one of the really bad cylinders. We had I think 30 or 35 psi on the compression test there, so this was really bad. So okay, it's hooked up now. I'll crank it back up to 30, and then we'll look at our leak down here, see what percent leak down we have. So here we go, cranking it up to 30, or 31 rather, and it looks like right now we got about 5% leak down, which is excellent. And the car's not even warm yet. You know, normally you should do this when after running the car and it's warm, and the piston rings would seal up better and it would be oiled and that sort of thing. So this is great. We're right where we should be. Okay, now that we have the valve train issues and leaks taken care of, we need to turn our attention to prepping the heads to reinstall back onto the motor. The first thing that you want to do is get all the debris off the surface. This was machined last time I had the motor rebuilt, so it's in pretty good shape right now. It's also an aluminum head, so you have to be real careful about removing debris from it. I recommend using a plastic blade here for scraping off the majority of the stuff, and for the stuff that really sticks, then go ahead and use metal or a carbide, but use very little pressure. It's very easy to damage the surface of this head. Just lightly scrape away and then brush away any foreign material that remains. The other thing that you want to do is check for the flatness of the head. The Ford spec for the flatness of this head is 3/1000ths within a 6-inch span. So I have a 1/1000th inch filler gauge here and a straight edge, and it's a good idea just to go several different areas, several different spaces across here, and then just check for the flatness. Originally this head was a little concave here between the cylinders, and I think they had to shave off about 12/1000ths. But this looks great now. I cannot get the filler gauge underneath there at all. So this is good. The next thing that you want to address is any oil or any contaminants on the surface. And what I like to use is lighter fluid. It's a really good solvent and gets oil off. And the way that I approach this is I just put a little bit on to the rag, and then I just kind of rub it around, and then I look at it and see if there's any dirt. If there's dirt still coming off, I continue the process until I don't see any more dirt. This is in pretty good shape as is. Okay, let's turn our attention to the block and prepping the surface for the head on the block. It's going to be pretty similar to that of the cylinder head, but there's going to be a few minor differences. Before I try to scrape any material off of this, I usually find that these alignment dowels get in the way, and so I like to remove these first. Usually you can just get in there and just yank on them a bit. Sometimes they're in there really good and you have to destroy them. If you do destroy them, just get some new ones down at the Ford dealer. And the reason I like to take those out is because when you're scraping, it's really difficult to get around this area with the alignment down. And this way we can just scrape over it and get all the foreign material off of there. And then when we set the head down, we know it's going to be on a perfectly flat surface. This is a iron block, so we can be a little more aggressive and use a carbide type scraper. And again, just cover all the area if you see anything. Also make sure it feels perfectly smooth as well. Oftentimes debris comes off and it falls down into the cylinders here, so if that does occur, definitely vacuum that out. One other thing that I like to do is move these pistons up and down and oil the inside of the cylinder block. You can't have them all down at the same time, obviously, so just rotate the motor until one of them ends up all the way down at the very bottom, and then just get the oil that you would normally use in the motor and a rag, and just put a little bit of oil on that, and then rub it around on the inside of the cylinder walls, because the first time this motor starts up, you don't want a dry surface there. You want to have some oil there to help protect it. Other than that, that's about it. Again, you might want to check you do want to check, make sure that there's no warpage, but iron blocks rarely ever warp. But definitely use a straight edge and a filler gauge just to verify that everything is in good shape there. Now let's put in the alignment dowels. In. You can hear when they bottom out, it changes note. There we go. Alright, once again, you want to make sure that you get brand new head bolts. They are torque to yield, so they're a one-time use only. Now, before I go any further, one important thing to check is to make sure that you have no debris in your bolt holes here. And a good way to check that is just take the bolts that you're going to use. Remember, the long ones, they go up on top, and then there's shorter ones that go down on the bottom. And make sure that they thread in easily by hand and totally bottom out. If not, you likely have some debris in the holes, and you'll either need to blow them out or clean them out somehow. Once you have all the bolts threaded into where it bottoms out, make sure that each of the bolts are displaying about the same number of threads to ensure that they've all bottomed out equally. Okay, now we're ready to lay the new head gasket on. And there is a left and right. The particular ones that I got are marked here with an R and an L, so this is the right side. But if you don't have that marking, the thing to look for is this little hole, because you'll notice at the other end it has two open ones. Well, the little hole side goes to the front of the motor. So it'll lay in here just like so. Alright, now we can lay the head down onto the block. And there we go. Okay, now before we put the bolts into the head, we want to make sure that these threads have plenty of oil on them. The reason for that is when we torque these bolts down, we want little resistance as possible to be on these threads. That way we'll get a more accurate torque reading. And I put it on here fairly liberally. Okay, now I can put the bolts down into the holes. Remember, the long ones go on top, and then the short ones go on the bottom side there. Okay, before we go any further, let's take a look at the bolt torquing sequence. Tighten the bolts in 3 stages in the sequence shown. Tighten the bolts to 15 pound-feet, and then 30 pound-feet, and then 37 pound-feet. Caution, do not loosen all the bolts at one time. Each bolt must be loosened and final tightened prior to working on the next bolt in the sequence. So, loosen and then tighten the bolts in 2 stages in the sequence shown. Tighten the short bolts to 18 pound-feet and then tighten an additional 180 degrees, and then tighten the long bolts to 33 pound-feet and then tighten an additional 180 degrees. Okay, let's start torquing these bolts down. The first stage is to 15 pound-feet, and we'll start with this one here, and then this one, and this guy. There we go. Okay, now we'll follow the same sequence again, but we're going down to 30 pound-feet this time. Okay, now one more time, same sequence, but to 37 pound-feet. Okay, so let's go ahead and finish this torquing up. So basically what we're going to do now is one at a time we're going to loosen each of these bolts in the sequence that was earlier shown, and then we're going to tighten the long ones to 33 pound-feet and then an additional 180 degrees. And then for the short bolts we're going to loosen and then tighten to 18 pound-feet and then another 180 degrees. So let's start with this guy here and loosen it. Okay, there's nothing on it. Okay, and that's a long bolt, so we're going to go to 33 pound-feet. Right there. And then plus 180. So I'm just going to basically do 2 90s here. There's 90. And then another 90. There's 180. Okay, to the next one, which is a short bolt, so we'll loosen this guy. And since this is a short one, we're going to just torque it to 18 pound-feet. So adjust my torque. It'd be nice to have two different torque wrenches here so I don't have to go back and forth. But here's 18. Right there, not a whole lot. Okay. And then 180. So again, I'll break this up into two 90s. Okay. There's 90. And another 90, so there's 180. And then I'll just continue the process, but going back and forth until I'm done. Yeah, I believe I forgot to mention one step in the video, and that's I did oil the bolts. You saw me oil the threads, but you also want to oil just below this head here, so when the bolt's twisting against the head you have minimal friction. So don't forget to oil that as well. Alright, I think I'll call it quits at this point. The other head is going to be identical to what I just showed you, so I don't believe I'll record that for you. So in the next video we'll go ahead and start reassembling the other parts of the motor, and hopefully we'll have this done real soon. Anyway, till next time, see you then. Bye.